So in 6.5, adding and subtracting fractions, this time we're going to actually add those fractions. And part 1 will show when the denominators are the same, and part 2 will show when we don't have common denominators. So let's look at a couple examples. Here in this example, we have two fractions with common denominators, and what we're allowed to do once we have common denominators is we can put the numerators together in the numerator, shall we say. We can put the two terms together in the numerator. So we'll put them both under over 12 because they're both over 12 here. We're allowed to do this, and since they are like terms, we're going to combine x plus 3x, which gives us 4x over 12. And now we will reduce this fraction. There's a common factor in those two terms. Both can be divided by 4. 4 goes into 4 one time. 4 goes into 12 three times. Try to write 3. There you go. So we're left with 1x in the numerator, or x. We don't write 1x. And in the denominator, we're left with 3. So x over 12 plus 3x over 12 equals x over 3. The next example, again, we have common denominators, so we can combine the terms in the numerator in one line, and you can write 7x minus 4x over 15. These are like terms. 7x minus 4x equals 3x over 15. And again, much like the problem previous, we could even simplify this. So we're going to divide that by 3 and divide this by 3. And we get 5. I'll write that, it'll be easier. Now some people look at this and they look at these problems and they think, okay, the subtraction, that subtraction has to go up to this term. So we notice that subtraction gets placed in front of the 4x. So we're left with, my final answer is going to be x over 5. So 7x over 15 minus 4x over 15 leaves me with x over 5. Again, we have common denominators. Now we have a variable in the denominator, but that doesn't change anything. As long as those two denominators are the same, we are allowed to combine the numerators. Five plus 9 is 14x. Not 14x, excuse me, 14 over 3x. Now in this example, we can't simplify. There's no common factor that goes into 3 and 14. So we leave it as 14 over 3x. X needs to stay in the denominator. Now we get a little more technical. We see that we have a negative outside, and we're going to have to do something special to that negative when we combine them all on the same line. We have a common denominator of 10. Both terms have 10 in the denominator. So my numerator is now going to become 3a minus the quantity 5a plus 1. So the tricky part of this is we have to distribute that negative. Since this negative is outside this term, it affects both of the terms in the numerator. So now I have to distribute that negative out. So my numerator is going to become 3a minus 5a minus 1. We distribute the negative to 5a and the negative to positive 1 over 10. 3a minus 5a, those are like terms. That would give me negative 2a minus 1 over 10. And that is my answer. There's nothing I can do to simplify this or anything. the negative 2 and the 10 cannot cancel because it's being added or subtracted to another term, another constant. So we can't cross cancel these. That's probably the most common error that students will make, is they'll try to cancel these two, but we can't because there is a term being added and subtracted to it. Let's look at this one. We have common denominators. We're going to combine their numerators. We have a negative outside there, so we have to distribute that negative. Or at least we have to show that representation. Y minus 3 minus the quantity 3y minus 5 all over 4. So that's now going to become y minus 3 minus 3y plus 5. We're distributing that negative to the other two terms. Negative into 3y makes negative 3y. Negative into negative 5 makes positive 5. Now we have two sets of like terms. We have y and negative 3y. We have negative 3 and positive 5. So that makes negative 2y plus 2 all over 4. Now, a couple things that we should be concerned about. We have a negative first term, plus we have a factor of 2 and a factor of 2, a common factor of 2 in both of the terms. So I'm going to factor out a negative 2, and that's going to leave me with y minus 1 all over 4. So we like that. That's nice. We've been able to factor a common term out, and now we can cross cancel. We can cross cancel. This negative 2 becomes negative 1, and this 4 becomes a 2. So my answer is the opposite, that represents the negative, times the quantity y minus 1 all over 2. Now, here's a very technical thing, or we can take this negative here and we can bring it down to the 2. We're allowed to remove it as long as it's multiplying a quantity. We can move it down and we can write probably a little bit more elegant way of stating that problem over negative 2. So that looks a whole lot cleaner than this. Both are acceptable. I would not redistribute that negative into there for the time being because we're just finding equivalent fractions. Okay, when we get to our final answer, after we've added and subtracted, we would want to leave that factor.